Warm welcome you all to channel Meet MIT, that is Math is Tricky.
Here in this video I'm going to solve these four problems, and the problem is here so that the following functions have neither maxima nor minima. Okay, so before solving these problems I'm going to write down two steps from which you will be able to solve any types of problems like this. So to this, or neither maxima nor minima. First one is if this condition is satisfied, then there will be no maxima, no minima. That is here dy by dx not equals 0. That is f dash x is not equal to 0. Okay, this is the first condition. Second condition is if dy by dx equals 0. So let's check second derivative. If dx square y second derivative is also 0, then we have to check but first is 0, second derivative is also 0. But if third derivative is not 0, then there will be neither maxima nor minima. These are the two conditions from which we will be checking whether the function will have maxima or minima. Whether the function will, so that if these two conditions are, any one of these two conditions is satisfied, then we can say that the function will have neither maxima nor minima. Okay, so let me solve the question and explain it for you. The question is first one. I'm solving the first question. Let's see here. Fx is x cubed minus 6x square plus 24x plus 4. So let's find first derivative at first. So it will be 3x square minus 12x plus 24. So let's simplify this. We can take here 3 common. So it is going to be x square minus 4x plus 8. And this can be written as here 3 x square minus 2 into 2 x plus 4 and which is 3 times x minus 2 whole square plus 4. This is our f dash x, and if we see this carefully as x minus 2 is greater or equals to 0, f dash x will be always greater than 0, because this term is non-negative term. Non-negative plus 4 is again positive, so we can write here we can write here f dash x is not equal to 0 for any real value of x. So we can say that, so there will be neither maxima nor minima. Okay, this is how we solve the first problem. So what I actually did is, here I have just found the first derivative, and then I expressed in such a way that we can easily say that the first derivative is never 0. Okay, once the first derivative can't be 0, if we can make first derivative 0 by any real values of x, so by the condition I just gave you, the first condition is being satisfied here, so we can say that there will be neither maxima nor minima for this first question. Okay, let's move to second question. So question number 2, if we say the function is here x cube minus 6x square plus 12x minus 3. As before, let's find first derivative. So it is here 3x square minus 12x plus 12. So what we can do, we can take 3 common, 3 is common, x square minus 4x plus 4, and it contains here 3x minus 2 whole square. That means f dash x and equals 0 at x equals 2. So let's find here second derivative. So second derivative will be simply here 6x, 6 times x minus 2. Okay, from here also you can get here 6x minus 12, 6 if you take common, so x minus 2 will be there, also equals 0 at x equals 2. And what about, let's check the third derivative. So it gives here simply 6 which is not equal to 0. So we can say here there will be neither maxima nor minima. Okay. Although first and second derivative are 0 for x equals 2, the third derivative is non-zero. Okay, we can make this as 0 for any value of x. So we can say that the function will have neither maxima nor minima. Okay, so let's move to question number 3. Hope you are understanding this, and if you like this video, don't forget to subscribe my channel and share among your friends. So let's move to question number 3. Number 3 is here. It's very simple. If you remember the condition I provided you, you can solve by yourself also. Y is given here x cube minus 3x square plus 6x plus 4. So let's first always find the first derivative. So it is here 3x square minus 6x plus 6. And if we take here 3 common from this, we will get here x square minus 2x plus 2. So it can be done as here 3x square minus 2 into 1 into x plus 1 plus 1, and which is again here 3 times x minus 1 whole square plus 1. Okay, so what we can write as x minus 1, the minimum value for this is 0. Okay, so we can write here, so y dash is always greater than 0. Hence we can write here, hence there will be neither maxima nor minima. Okay, and there will be no maxima no minima, because this first derivative for this function will be never 0. Okay, hope you are getting this, and if you have any confusion, don't forget to share with me so that I can help you. Okay, the last one question, number 4. We are given here y equals x raised to power 5 minus 5 x raised to power 4 plus 5 x raised to power 3 minus 1. So let's check its derivative at first derivative. So it's there 5 x power 4 minus 20 x cube minus 15 x square. So we can do here, we can take x square common. If we take here x square common, so we are getting how much? And okay, so easily we can see that for the given point, and we can say that here y dash equals 0 at x equals 0 at x equals 0. So let me write here at 4 x equals 0. So let's check here second derivative. So second derivative will be here 20 x cube minus 60 x square minus 30 x. So again we can see that y double dash equals 0 for x equals 0, and let's say here, and third derivative y triple dash, it is here 60x square minus 120x minus 30. Here y triple dash equals minus 30, that is not equals to 0 for it is not equal to 0 for x equals 0. Even for x equals 0, although first and second derivative are 0, third derivative is not 0. So by our second condition, if first derivative is 0 and second derivative is 0 but third derivative is not 0, so in that condition we can say that there will be neither maxima nor minima.
Because of your support.
Okay?
Because of
No.
your support.
There will be neither maxima nor minima.
This is
I
how
am uploading and solve many more videos
your problems
for you.
and
If
hope
these
and
videos are being helpful for you, okay, please share your feelings, your ideas, how you are feeling, how these videos are helpful for you, whether you are getting benefited from these videos or not. I'll be happy with your feedback. Okay, so let's start today's video with some problems here. I have some problems for you. I'm going to solve it and explain it for you. Okay, today in this video I'll be solving some problems regarding concave upward or downward for the function. Whether the given function will be, whether the given graph will be concave upward or concave downward, how will we know? Before solving, let me write you the steps. Let me provide you the step so that it will be easy for you to solve. Okay, the steps for this steps. Okay, so first one is find f dash x, that is dy by dx. First you find dy by dx, that's the first step. Second step is find f double dash x, that is second derivative. Okay, third step, now examine the sign. Examine the sign of f double dash x. Okay, so now the fourth one point, that is the last point. If f double dash x is greater or positive, it will be concave upward, concave upward, and if f double dash x is less than 0, that is negative, it is concave downwards. Okay, very simple. Out means upward, down means downward. It is very easy to remember also. Okay, so remember 4 steps, just 4 steps. First one, find the first derivative. Second step is find second derivative. Third step is examine the sign. Okay, check whether the second derivative is positive or negative. At last you make the conclusion, conclude that it is concave downward if the second derivative is negative or less than 0, and your conclusion will be the curve will be upward if second derivative is positive, it is up. Okay, so now let me solve the problem for you. These are the 4 steps, and by these 4 steps you can solve any type of problems regarding any type of problems like this. Okay, let me solve the problems for you. The first one problem is here. First one problem is y equals x power 4 minus 2x cube plus 5. So as before, our first step is find first derivative. So 4x cube minus 6x square. So find second derivative. second derivative is here 12x square minus 12x. So now what we can do here, we can take 12x as common. So we are getting here x minus 1. Now we have to check whether this is going to be positive or negative. So before that you find at what point this is going to be 0. So easily we can see that the second derivative will be 0 at x equals 0 and for x equals 1. Now when x is, now we'll check for this 3 interval, okay, 3 intervals. So for x less than 0, second derivative, which if we take here minus 1, so suppose here we are taking x equals, you can do mentally also, so x equals minus 1, that is less than 0, so this is here y double dash will be how much, so we can just do here rough to know what is the sign. So it is here simply 12 minus, and then here again minus 1 minus 1, so minus minus plus, that is second derivative will be positive, so we can write here, so second derivative is positive, so the curve will be concave upward for x greater than x less than 0, for x less than 0. This is first part. When now let's move to the second for this. So when x belongs to 0 and 1, so if we take here 0.5, so this will be positive, this will be negative, so second derivative is negative, so there will be concave, the curve will be concave downward, okay. When x is greater than 1, take any value greater than 1, so if you take a 2, so this is positive, we can see a second derivative is positive, so it will be concave upward, okay. This is the solution for first question. Hope you understood this. If you have any confusion, you can ask me, you can write your confusion in comment box so that I can help you. Now let's move to question number 2. Number 2, y is given to be here x power 4 minus 8x cube plus 18x square minus 24. So as before, find first derivative. It is here 4x cube minus 24x square plus 36x. Let's find second derivative. So simply here 12x square minus 48x plus 36. Now we can take here 12 common, so it will be simply x square minus 4x plus 3, and this can be factorized as x square minus, it is here minus 3x minus x plus 3, so it can be factorized as x common x minus 3 minus 1 common x minus 3, so that will have 12 times x minus 1 and x minus 3. As before, now we have to check whether the second derivative is positive or negative. For that, you first find at what point this is going to be 0. So the point here for x equals 1 and x equals 3, it will be 0. So now as before, we can find here 3 intervals for, now let me write here, let me show it for you. So we have got here second derivative equals 12 times x minus 1 x minus 3, okay. So when, as before, let's check here, x is, when x is less than 1, we can check here second derivative, simply put any value less than 1. So if you put here 0, this is negative negative, so what will be negative means second derivative will be positive, so it is concave, concave, concave upward for x is less than 1. So when x belongs to 1 comma 3, so you can take here any value between this. So suppose here 2, so this is positive, this is negative, means second derivative will be negative, so it will be concave downward. Very simple. So it is here downward, and when x is greater than 3, second derivative will be obviously see here. This is also greater than 3, means you can take here 4, 4 minus 3, 1, and 4 minus 1. So both positive, so second derivative will be positive, and it is here concave, concave positive means upward. This is how easily we can determine whether the graph will be upward or downward depending on the sign of second derivative. Okay, so let's see another question. Hope you are understanding this, and you can also solve this type of problem within this minute if you practice. Okay, so let's move to question number 3. Here y equals 3x power 5 plus 10 x cube plus 15x. So first derivative is here simply 15 x power 4 plus 30 x square plus 15. Second derivative will be 60 x cube plus 60 x. Okay, so what we can do here, we can take 60 x common, and x square plus 1 will be there. So now this is only 0 for x equals 0, so it is only 0 for x equals 0, so there will be y double dash, it will be 0 for x equals 0, because this is always giving positive value for any real number. So when x is less than 0, this is going to be negative. Okay, so second derivative will be less than 0, concave, so the curve will be concave downwards, and when x is greater than 0, means any positive 1, 2, 3, 4, 5, whatever you can take, second derivative is positive, so concave upward. Okay, it's so simple and it's so easy if you practice and if you understand and if you try to do by yourself. So remember always, it's all because of practice and your hard work. Okay, so if you are understanding, let's solve question number 4 for you. I'm going to solve question number 4 and explain it for you. Y is given to be here x cube minus 9x square. Also we are given the function is defined on minus 5 comma minus 2 comma 5. So y dash will be how much? 3x square minus 18x. And what about the second derivative? Second derivative is going to be 6x minus 18. So we can take here 6 common and x minus 3. So y, let's see here. So second derivative will be 0 for x equals 3, and this 3 lies in this interval. This is what we have to check. The interval is given, so that we have to check whether the value of x lies in this interval or not. Only we can choose that value of x which lies in the given interval. So 3 lies in this given interval. So let's take here now, check the sign of second derivative. When x is less than 3, so second derivative, take any value less than 3, so 2, so this is going to be negative, so curve will be concave downward. Okay, and then when x is greater than 3, take any value greater than 3, x is greater than 3, so second derivative 3 means you take here 4, so 4 minus 3 it is positive, so it is positive, so concave upward, the curve will be concave upwards. Okay, this is our concave upward, concave downward. If the value is less than 0, it is downward. If the second derivative is more than 0 or positive, it is always upward. Okay, so another question for you, question number 5. Y is given, or fx, that is fx, y and fx same. So 2x cube minus 6x square plus 5. So what is first derivative? It is here 6x square minus 12x. So y double dash is how much here? 12x minus 12, and if we take 12 common, we are getting here x minus 1. That is y double dash is positive for x greater than 1. If it is x is greater than 1, 2 means 2 minus 1 positive, so curve will be concave upward for x is greater than 1, and y double dash we can easily check here less than 0 if x is less than for x less than 1. So as before also we can check here for x equals 1 it is 0, so for x less than 1 it is negative, for x more than 1 it is positive, so for less than 1 all the values of x it is negative, so curve will be concave downwards. Remember, this is what I have done, just in short I am telling you. So if the second derivative is positive or greater than 0, the curve will be upward, concave upward. If the second derivative is less than 0 means downward, the curve will be downward. Okay, hope you understood this. Thank you so much for tips about how to solve problems based on application of derivative, and mostly I'll be dealing with some word problems. Okay, so let's start with the first problem. The first problem is here. A man who has 144 meter of fencing material wishes to enclose a rectangular garden. Find the maximum area he can enclose. Okay, so always remember, if there is maximization or minimization of something, that is related to derivative, that is related to application of derivative. So you can see here the maximum area we have to find, so it is related to application of derivative. So question number 1, let's see here, let p and here let here let's draw one figure also. So I think with that figure also we can do let x and y denote the length and breadth of the rectangular garden with perimeter P and area A. Then we can write here P equals twice x plus y, and here P is given to be 144. This is P here. 144 equals 2 times x plus y. So we can write here 72. Therefore y equals 72 minus x. Okay, this is our first equation. So now as we have to maximize the area, so use formula for area. We can write here area equals L into B, that is x into y, and x times y is simply 72 minus x, and it gives here 72x minus x square, that is A. So let's find here A dash will be how much? A dash will be 72 minus 2x. A double dash will be how much? Yeah, simply minus 2, which is less than 0. So area will be maximum for a dash equals 0, and it gives here 72 minus 2x equals 0, that is x equals 36. And now we can find the maximum area. What we have to do, what is the maximum area? He can enclose, therefore we can write here y equals 72 minus x, that is again 36. There, so maximum area will be 36 into 36. So simply it will be 1296. It is simply meter square. This is how we can find, or also we can substitute the value of x, this value, in this function. So okay, here also we can put, and from that also we'll get here same thing. Okay, so this is our answer. Okay, so this is how we have solved the problem. So remember what actually I did here. Perimeter was given, so I used the formula for perimeter, and then I have just changed the two variables. We have two variables here, so one into another. So I have just found the value of y in terms of x. Now as we have to maximize the area, so I have used the formula for area. Area is length into breadth, and then I have just substituted the value of y, so that we'll have the function, that means area in terms of single variable. Now we know that how to find local maxima or minima. The steps I have already given you. So first we find first derivative, then we'll move to second derivative. From second derivative, by looking at sign, we'll know whether there will be maximum or minimum value. As it is negative, so area will be maximum. Now to find the maximum value, at what point the area will be maximum? For that we are finding the stationary points or critical points by making first derivative 0. From that we got here x equals 32. Also we are getting here the value of y, that is our breadth, 72 minus 36 is 36, and now area is 36 square. So simply we can check here 36 square is we can check 6 square is 36 here. So 6 3 is 18, 18 into 2 36, 36 and plus 3 39. So 9 here, 3 is 9 plus 3, it is 12. Okay, that's correct. Now let's move to next question. Another question is here. We have to prove, the question is, first one we have solved. Now move to question number 2. Question number 2. So that the rectangle of largest possible area for a given perimeter is square is similar to first one. So for as before, let's suppose here number 2, let x and y, let x and y be length and breadth of a rectangle with given perimeter P and area A. Then what we can write here as before, P can be written as 2 times x plus y, and from that we'll get here y equals P by 2 minus x. So, and area will be x into y, that gives here x, value of y is P by 2 minus x, it gives here px by 2 minus x square. So if you find here first derivative, we'll get here p by 2 minus 2x, and a dash equals 0 gives p by 2 minus 2x equals 0, that is x equals p by 4. From here also we can see the perimeter is 4 times x, means it is going to be a square. That is what we have to prove. Okay, so let's find here second derivative. Second derivative is how much? We can see here easily second derivative will be minus 2, which is less than 0, so we can write it. So area will be maximum at x equals p by 4, that is y equals, also we can write here, p by 2 minus p by 4, it is here p by 4. We can see here the value of x and y, that means length and breadth, that is here we can see x equals y equals p by 4. So we can say that the area will be maximum if rectangle becomes square. This is our complete solution. Hope you understood this. Thank you so much. God bless you. See, this is number 3. A window is in the form of a rectangle surmounted by a semicircle. If the total perimeter is 9 meter, find the radius of semicircle for the greatest window area. So I think if you want to draw the figure is like this. Figure is okay. So if it is here, if you take here this as B and this is L, this is B, this is going to be here, it is going to be R equals L by 2. Okay, so if we consider here, the figure will be like this. Let L and B denote the length and breadth of the rectangle, and R, that is equal to L by 2, be the radius of the semicircle. Then we can write here, then the perimeter P, that is the perimeter of window, we can write here with area A can be written as here, perimeter will be here B plus L plus B plus, so perimeter for semicircle will be 2 pi r, so it will be simply pi r. So 2b plus is given here 9 plus L plus pi r is L by 2, so we can write here L by 2. Now let's find the value of b, so we can write here b equals 9 by 2 minus L by 2 minus pi L by 4 equals b. That is equation 1. And we can write here A equals area of window means area of rectangle plus area of semicircle, that is pi r square by 2. It can be written as here A equals L is L, and then this is here 9 by 2, this is 4.5 minus L by 2 minus pi L by 4, plus we can write here pi L square by here it. Okay, so let's simplify this and find our answer. So let me write this and simplify it for you. So now let's find here, we can write here A as, this is the question number 3. So A will be simply, now if we simplify, so A is 4.5 L minus L square by 2 minus pi L square by 4 plus pi L square by 8. So we can write here simply. Now let's find a dash, so that it will be here 4.5 minus 2l by 2 means l, minus 2l by 4 means pi l by 2, and then plus pi l by 4. So a dash equals 0 gives the value of l, so we can find here l plus pi l by 2 minus pi l by 4 equals 4.5. Let's find here. Let's simplify this to get the answer. So we can write here l, and if we simplify, so we'll be getting here, this is the LCM is 4 from this, and it is here 2 minus 1, so we will get here pi l by 4 equals 4.5, or we can write here l common, so we can write here 4 plus pi by 4 equals, this is actually 9 by 2, so we can write here 2. Therefore the value of l is simply 18 by pi plus 4. This is our l. Now we need to find the value of a double dash. Double dash will be how much? Let's check here. A double dash will be simply, this is minus 1 and minus pi by 2 plus pi by 4. And if we simplify, a double dash will be minus 1 and minus, it will give here minus pi by 4. So this which is less than 0. So area will be what? Area will be maximum. This is what we have to find. Area will be maximum. For maximum greatest window area, maximum or greatest is something where at when l equals 18 by pi plus 4, that is r equals l by 2 means it is here 9 by pi plus 4 meter. That's how it's. Okay, if you understood this, actually what I did here, I've just followed the steps that are given to you to find the local maxima or minima. Find first derivative, make it 0, find second derivative, and check the sign of second derivative at the point or at the stationary points that are obtained from second step. And at last, if second derivative is minimum, the area will be max. If second derivative is negative, area will be maximum. If second derivative is negative, area will be maximum. If second derivative is positive, area will be minimum. If second derivative is negative, area will be maximum. This is what I am using. This is how I solved it. Now let me solve the next question number 4 for you. Here, question number 4 is like this here. Okay, so a closed cylindrical can is to be made so that its volume is 52 cm cube. Find its dimension when the surface area is maximum. Okay, so again here there is maximization of surface area, so it is related to application of derivative. Now let me solve it for you. So what we are given here, volume is given 52. Now surface area, so volume of cylinder will be what will the pi r square h equals 52. So we can write here h equals 52 by pi r square, that is first formula. So you can write the like this. And then surface area, we know the surface area S is here 2 pi r square plus 2 pi r h. So let's put the value of h, so that we will get here s equals almost 2 pi r square plus 2 pi r h is 52 by pi r square. So pi r square and pi cancel, so it is here r, that is s equals 2 pi r square plus it is here 104 by r. So let's find here s dash. First derivative will be 4 pi r minus 104 by power minus 2. So second derivative also let's find. Here it will be 4 pi minus minus plus 208 by r cube. Okay, now if we let's simplify the second derivative, and if we take here s dash equals 0, we'll get the value of r. So let's simplify this. It is for s dash 0, we get here, this implies here 4 pi r equals 104 by r square. It gives here, this is how we are getting here, it gives here r cube equals how much, 104 by 4 pi. So it is giving here the, simplify this further, so we can write here or r cube equals how much. So we can cut this by 2 4s and 2 6 26 by pi, or we can write here if needed r equals 26 by pi 1 by 3. Okay, this is the value of r. So if we put here the value of r in second derivative, we'll be getting here, see here the second derivative is, and for r equals 26 by pi whole power 1 by 3, s double dash becomes, check here, 4 pi plus 208 by r cube. R cube is 26 by pi, 26 by pi. So this is how much? This is 8 times. So it is here 12 pi greater than 0. So we can say that greater than 0. So surface area will be, so we can write here, so surface area will be, here it is, it will be minimum, this is minimum, will be minimum for r cube equals 26 by pi. Okay, now we have to find the dimension. So let's find the value of h also. So how to find the h? So we have here also, we have the value of h equals 52 by pi r square, or we can write here h equals 52 r by pi r cube, and then 52 r by pi r cube is how much? R cube is given there 26 by pi. So these two cancel, it is here simply 2r, that is, therefore h will be double of the radius, and r equals, we will calculate 26 by pi 1 by 3. Okay, this is your answer. So the value of r will be 26 by pi, cube root of 26 by pi, and the h will be double of the radius. To have the minimum surface area 5. Okay, so question is like this: if a gardener having 120 meter of fencing material wishes to enclose a rectangular plot of land and also to erect a fence across the land parallel to two of the sides, find the maximum area he can enclose. So question number 5, for 5, the figure will be like this here. Suppose we are taking a rectangular land here. So in middle we are drawing so that it will be erect. So this is L, 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 this is B, B. So for this perimeter, P will be simply here 3L plus 2B, and perimeter is given here. This is 120 equals 3L plus 2b, and if we find the value of b, so it is going to be 60 minus 3 by 2 L, that is 1. Now we have to find the maximum area, so area will be L into B, and simply L times B will be here, so 60 minus 3 by 2 L, and it gives how much? So 60 L minus 3 by 2 L square. This is A. Let's find here. A dash will be how much? A dash will be 60 minus 2L, means 2 and 2 cancel, so it is here simply 3L. A dash equals 0 implies 60 equals 3L, therefore L equals 20. And if we calculate here, and then B will be how much? B equals 60 minus 3 by 2 into 20. So if we give here 20, so 10, so 30. 60 minus 30 is here again. 30 equals 30. B is 30. Now, what about the second derivative? A double dash will be how much? A double dash will be simply, you can see here, minus 3 less than 0. So we can write here maximum, the area will be maximum area, and for what is the maximum area? So we can find here, so let's write here. So therefore area max will be simply 200 into 300, that is 600 meter square. Also we can obtain the maximum area from here also by putting the value of L. Here also we'll have the same answer. 60 into value of is 1200 minus 3 by 2 L square means 400 by here. 1200 minus, it is, I think, how much? 400 means by 2, 600. 1200 minus 2, 600 will be again 600. That's our answer. Okay, hope you understood this. If you have any confusion, you can ask me, you can share through your comments, okay, so that I can help you. Let me solve another problem. Question number 6. This I have solved now, part 6. It's very simple. So we have to find two numbers with sum is 10. So let the numbers be x and y, so that x plus y equals 10. So we can write here y equals 10 minus x. This is first equation. Now let s be the sum, which is the sum of square of the numbers. That means x square plus y square. So we can write here x square plus y square is 10 minus x whole square. So s dash, let's find s dash is 2x plus 2 times 10 minus x. Okay, so it is going to be here minus 1 also. So s dash equals 0 implies here 2x minus 2 times 10 minus x equals 0. How much we are getting here? 2x equals 2, 10 minus x. So 2 and 2 cancel. So we have here x equals 10 minus x. Therefore 2x equals 10, x equals 5. And we can see here y equals also 10 minus 5 equals 5. Now not only this much, we can find the second derivative also. Second derivative is how much? Let's find the second derivative. So that we'll be getting here 2 and here minus 2, and then again here minus 2, and what is this second derivative here? It is minus 2, and derivative of this is minus 1. Okay, so it is going to be 2 plus 2, that is 4, which is greater than 0. Second derivative is greater than 0 means the sum will be minimum. So the sum will be minimum at x equals 5, y equals 5. So this 5 comma 5 are our required numbers. Hope you understood this, and if you have any confusion, please share with me. Keep on practicing. Whatever steps I have given, people, please you memorize them and then use them while solving the problems. Thank you so much. God bless you.
Thank you so much for watching my video. I hope you like this video. Please do share this video with your friends, in your circle, in your social media, and please don't forget to subscribe my channel. Thank you so much. God bless you.